All right, our next presenter is Harold Hudson, who's a professional engineer and professional geologist with BRS Engineering in Riverton, Wyoming. Harold has worked with the Wyoming Abandoned Mine Land Program since 1995, working on a wide variety of projects, including abandoned open pit and underground uranium and coal mines.
Thank you.
That should work.
All right. Well, to start with, I'd like to acknowledge the Wyoming Abandoned Minelands Program. I see Don Newton, the program administrator here. And also here is Brett Bergstrom, who is the AML Mine Fire Project Manager. So we've been working with Brett on actually this project, among others. And I apologize in advance. When I originally submitted this presentation, I did it to the subsidence group and not the mine fires group. But this does include a mine fire, so we'll talk about that as well as some of the other subsidence portion of the work. I'd also like to acknowledge Ryan Reed of BRS. He is our project manager for the drilling and grouting projects, and he put this presentation together. So you get the second string guy here for the presentation. So. A little bit of history in the Rock Springs coal field then. This map would show the Superior Mining District, the Rock Springs. This is Interstate 80, where the Transcontinental Railway comes through. As some of you may know, this was a very early Western site, 1860s, because of the construction of the Union Pacific Transcontinental Railway through there. And the coal mines of this area were integral to the expansion of the United States at that time. These are 1 mile squares. These boxes here, or the black outlines, are the outlines of coal mines. So you can see that it's very extensive. There were several coal mining camps, many of which grew together to form the current city of Rock Springs. There's over 120 known mine sites in Sweetwater County, Wyoming, and over 20,000 acres are undermined, of which 640 acres lie directly beneath the city of Rock Springs. So there's a lot of impacts due to past coal mine practices in this area. The Wyoming AML program in general has focused on the near surface hazards. We've closed numerous open portals and subsidence features and stuff, which has been the subject of past talks I've gave at past NAMLIP conferences. But a lot of the focus of the AML program is now moving down dip into the deeper areas and also addressing coal mine fires. So. With that, again, a little summary here. BRS has done since 2015, 17 major drilling and grouting projects for AML in the Sweetwater County area, total construction costs of $71 million. One example of it is the Head Start here in Rock Springs. You can see the kids. Here we're grouting shallow underground mine workings immediately in the adjacent vicinity of their school. And over 300,000 cubic yards of grout has been installed, and that's significant. Certain landowners, when they see truck after truck of grout coming to their driveway, and suddenly they realize like there's more grout been installed under my house than the size of my house, it's awe-inspiring to someone who doesn't necessarily understand what's going on in the subsurface. Here's a nice historic photo. Somebody asked in one of the previous presentations, how did the mines get started? I love this guy smoking this stogie in the underground mine workings. So that's our current project here. We're talking about the Rock Springs number 7 and 9 project. It is located north of the city of Rock Springs. It's a little different than ones that we would be addressing under residences in the Rock Springs area. In this case, there is a interstate gas pipeline right-of-way that we're going to be looking at just north of Rock Springs. This is a video, and I'll see if my videos will play. Here we go. This is a little UAV video of the thing. I would like to point out a couple things. This barren area right here is an excavation area where a surface expression of a coal mine fire was excavated on a past AML project. Again, that idea that we were working some of the shallow things first. This is the pipeline right away. There's 3 pipelines that come through this area, 2 that are active gas pipelines, as well as one that's filled with inert gas that's inactive. And nearby, you can see these other disturbed areas were areas where we did massive excavation of shallow subsided areas where there was massive collapses. which is really the most cost-effective way to deal with subsidence. In the case of this gas pipelines, obviously you're not going to be excavating under active gas pipelines. And so a different methodology was required in that area. I'm going to go ahead and pause that. This is an aerial overview of the same area. This is the coal seam outcrop working around here. And this is the area I pointed out in the flight that where the past excavation of coal fire workings occurred. And then this is the right-of-way of the 3 interstate gas pipelines. I would point out that there's active fire all the way around this outcrop, and that the fire has burned extensively under this area, which was mined room and pillar. And that's what gives this strange appearance to the surface where the fire has killed vegetation. Most of this area is no longer active, or if it is, it's relatively low. So when, like some of the previous presenters talked about the prioritization of these areas, they're not having a significant impact to infrastructure or anything. They're just sort of out there in the middle of nowhere and not a high risk. So they would fall low on the totem pole of things to do for the AML. But certainly shallow underground workings under interstate gas pipeline met the criteria for AML to consider it. What was not known initially when this project was started is that this fire, which was thought to have been sort of stopped in this area, had actually begun to burn up and around the outcrop and move to the north, which we discovered when we began doing some investigative drilling. So after we drilled the site out, and this is based on a limited number of holes out here, so take this part of the map with a grain of salt. But what you can really see here is you see where the mined out workings are. This is the outcrop line. Here's some of the entries from the surface. This area is unmined barrier pillar coal. And then here is the first, what the undergrounders called entries. It's a haulage way on strike where the rooms were often mined up dip. As we composited our downhole thermocouple readings from the drilling that we did, what became apparent is that this haulage was on fire and it was passing under the interstate gas pipeline area at a depth of approximately 35 feet. So that quickly became a priority. As we were talking to the gas pipelines to gain acceptance for the project and to get consent from them, as well as to work with them to establish some safe operating procedures for drilling and grouting around interstate gas pipelines. This, and I will not name the company in case it affects their stock portfolio or something like that, their stock price, but this particular interstate gas company said that this site immediately jumped to the top of their list for their hazards. And this is a gas pipeline that traverses much of the country. So once they realized the magnitude of what was going on, it became a high concern, and they were obviously very eager to work with the state of Wyoming to mitigate this area. The other thing that's you can see here, by the way, is that there are places that are unburned coal, and we will be addressing some of that in future work to create a cutoff wall through this area to make sure that the fire doesn't make an end run around our work and get into the unburned barrier pillar under the pipeline, which would be very difficult to mitigate because there's no void that you can grout into. And Brett and I are actually working on a project. We should be excavating that this winter. This is a cross section kind of then showing through the same, you can see that same haulage here. And what we've done here is represented that showing the burning area at a depth. If you look at this, the scale here is 50 feet. So less than 50 feet from the surface, as I mentioned. The other thing in the remainder of our drill holes, the entirety of this project has less than 100 feet of cover over the mine workings. And in certain places, you can see that the void and rubble is propagating up towards the surface due to the fact that, the deeper they got, the better their roof was. They started extracting more and more pillar and weakening the overburden. And again, I mentioned the firewall excavation. That will essentially occur in this portion that's the shallower area, the unmined portion of the coal. So what this is just a drill hole layout showing what our plan for the drilling and grouting was. And this is a depth isopac mapping that shows, our maximum depth up here in the 100-foot range. So this is, only addressing the very shallowest areas of this particular mine underneath these gas pipeline right-of-ways. Our drill hole spacing in this case is 35 feet. That's been kind of proven in the Rock Springs coal field as an effective spacing to ensure that when we pressure grout that the holes are in communication with each other, that as you grout the next hole, it'll push back to the prior hole area. This, I won't read this to you, but this is kind of an interesting collaborative specification that came from our work with the two different pipeline companies to establish some safe working protocols for drilling and grouting around pipelines. And so basically, we had certain things that we needed to do for crossing the pipeline and some things that we were going to do to make sure that we didn't drill into an interstate gas pipeline, which would obviously have calamitous effect. So this photo just kind of shows some of these things put into action here. You can see a drill rig, in this case, is drilling down to intersect the workings. There's a grout pump here that's being fed by mixer trucks, putting our cementitious grout into the workings. These barrier fences create no-go zones around the actual pipeline alignments themselves. These mounds of dirt were installed over the pipeline so that we had a place to drive across the pipeline in a couple areas. This is a vac truck. All of our drill holes were potholed in advance so that we didn't send steel down the hole based on a locate and thought that the pipe wasn't there when indeed it was. By potholing the holes, we ensured that we didn't hit the pipe with the drill steel. And so that gives you kind of a good idea of just the general working protocols that we established in conjunction with our partners, the pipeline companies. This is just kind of another photo showing how close the pipeline alignment itself is in this protected corridor while we're grouting in the adjacent area. Here's some representative photos while we're drilling, collecting cuttings. When we grout, we install the trimming pipe all the way down to the workings, and then as we grout it, we retreat the pipe in 2-foot increments while we're injecting with the grout injection pump to ensure that we're pushing grout fully into the mine workings as we retreat out of the hole. And you'll notice the pressure gauge here. We have established protocols for what safe operating pressures we can grout at the wellhead to ensure that we don't cause heave of the surface. And whoops, too many buttons. This is a laser level with audible repeaters that pick up. So in the event that we were to actually pressure up and begin to heave the ground surface, it'll set off an audible alarm and let us know to cut the pumps so that we're not moving the ground. This is more important in the case of working around residential structures and so forth, that you don't want to, lift somebody's garage off its foundation or something. But that's never been done. This is just a nice historic photo from one of the future targets of the AML program, the Lion Coal shafts. This is a underground photo of a shaft that we'll be grouting in the near future. For this project in particular, we did 300 holes. 55% of our holes encountered rubble, which makes sense in a room and pillar, roughly 50% extraction mine. This project installed 30,000 yards of grout, up to 100 feet of cover, and the total cost was about $7.4 million. That was last year's dollars. Obviously, everything's going up. So there's just a fun picture. A good day on the job. This is another little short video, and I think I have time for this. It's sped up something like 12 times, so it'll make you dizzy and seasick. But what this shows is the camera descending down our drill hole. You can see the depth in the upper corner there to tell you where you're at. It's looking at some rubbleization that has occurred by collapse of the mine roof that will get grouted later on as the trimmy pipe is pulled out of the hole. And as this goes, what I'll explain is how this affects the mine fire. In the areas that we grouted into the active burn, someone asked earlier about standards for cleanup of coal fires, and Tetra Tech had a nice diagram, the triangle: heat, air, fuel. What we're attempting to do by grouting into the workings in, and now you can see the room, you see roof collapse in the area, you can see some coal in the rib. This is at 62 feet below surface, plus or minus. When we grout into the workings, what we've essentially done is removed the air, and we've sealed the surface of any remaining coal that is in the pillar. And so we've done this. If any of you saw the presentation we did for the last year's online conference for Reliance, we did some verification drilling after the fact in Reliance, where we also grouted into an underground burning area, and we took core of that area, and we can, with 100% certainty, certify that that area has been quenched and cooled and is no longer burning. Okay, what you're seeing now is some of the cementitious grout moving into the room. And again, it's sped up. You'll begin to see it flowing in. So this is in a hole ahead of the current injection hole. And so you'll see it flow along for a little while, and then it'll maybe find another path of least resistance into another adjacent room. This is being injected at about 400 PSI at the bottom of the hole. So that gives you a rough idea of the speed that it's entering the workings. And so what you can obviously see is even stripping some coal off of the roof as it passes through previously mitigated areas, and there it's going to be covering up the coal. So the idea is basically to smother the fuel, to isolate it, and to prevent it from continuing to burn. On a scale of cost, obviously with shallow workings, if you can excavate them, the cost of doing that is $50,000 an acre, or maybe $100,000 an acre, depending on depth. Grouting is certainly one of the more expensive options at roughly $1 million an acre. However, in not all cases, like at these kinds of depths, you're not going to excavate it, nor are you going to excavate under an active interstate gas pipeline. So this is a very effective tool in the places where it will work. Okay, so that's all I have. This is another great historic Wyoming photo, by the way, underground mine shovel. If you have any questions, I'd be glad to answer those. And maybe in closing, because again, as I mentioned, I did not tailor this for mine fires specifically. I was just kind of talking about mitigation of this pipeline. Fires were one thing we did, but the AML program in general for Wyoming, we do have 26 active mine fires that AML is monitoring and looking at prioritization for funding for mitigation. And so, I think one of the things in our initial slide was Wyoming's motto from prior the reauthorization, our work's not done. That certainly rings true in the mine fire arena. So